Okay, so given this generic function y equals f at x, we're going to replace y with y minus 5, and we're going to see that we will get a vertical shift translation of 5 units up. Here's an example to follow along with. So here's the example we're going to use throughout all of these here. So we're going to start with a function you're really familiar with. F at x is equal to x squared. Remember, y is f at x. So we're just looking at that. Okay. Now, if I took that, y equals x squared, and I replaced y with y minus 5, then I would get y minus 5 instead of y is equal to x squared. And if this were Math 11 and I asked you to graph that parabola, what would you do to that equation? Yeah.
Move the 5 to the other side.
And you would get?
Y equals x squared plus 5.
Good. Okay, and if I ask you, where's the vertex for that? At 0 and 5. Where was the vertex for this one? At 0 and 0. So what happened to this parabola? It moved 5 units up. Okay, so we're just going to really kill this, okay? We're going to just repeat it till like there's no questions to be asked. Replace y with y plus 3. So I've got y equals x squared, a vertex at 0, 0. If I replace the y with y plus 3 equals x squared, then if I solve that for y explicitly, I would get y equals x squared minus 3. Where's the vertex for this parabola? 0 and negative 3. So what happened? I took this and I moved it 3 down. Okay, so before we move on to the x's, note that when you replace y with y minus 5, you move it 5 up. Look at your parabola example. You replaced y with y minus 5 and then you defined it explicitly. If you replace y with y plus 3, you're going to move it down. Look at your parabola example. And then you defined it explicitly. You moved it 3 down. Okay, let's move on to what happens with the x's. If I replace x with x minus 5, then instead of y equals x squared, I get y equals, okay, so this is what I mean by composition. If f at x is x squared, the function at x minus 5 is equal to, every time I see an x in my function, I replace it. Whatever was in here has to go in for here. I replace the x, which is being squared, with x minus 5. I had to compose it. Okay, so we end up with not y equals x squared, but y equals x minus 5 all squared. Okay, it's explicitly defined. Tell me where the vertex is. At 5 and 0. So you replaced x with x minus 5, and you moved it 5 to the right. And last of all, we're going to replace x with x plus 3. So instead of y equals x squared, we're going to compose it with x plus 3. We're going to get x plus 3 all squared. Which means we've got a vertex at negative 3 and 0, which means we moved it left by, there's a typo there, would you please fix that, by 3. Okay, so anything that happens to the y we call vertical, anything that happens to the x we call horizontal, If you are wondering what happens with any of your translations, left, right, up, down, come back to this box and look at those examples, and it should clarify them all for you. Okay, so here is a summary so far. And I'm just going to say for h and k values greater than 0. If I start with y equals some function of x, and I change that, I transform that to y plus k is equal to some function at x minus h. Then this k, then we could define this explicitly by moving the k over. Then looking at this compared to that, you'll know that this k moved it k units down, and this h moved it h units right. When it's explicitly defined, note that the k minus k moves down. That sounds logical. Minus h moves right. It kind of seems opposite of what you'd expect. Go back to what you know about the vertex of your parabola, and it will all make sense to you.